I'm a bit warm, I'm a bit sweaty. Our skin microbiome must be going crazy right now. So I want to tell you a story about me back in primary school. When I was really, really young, I was shown a really simple experiment. The experiment included an ultraviolet dye, an ultraviolet light, and my hand. All you really needed to do was shine the ultraviolet light and it would glow. Very simple. But in essence, this is meant to teach us good hand washing technique because the dye is supposed to represent microorganisms. Microorganisms that could be transferred from person to person. I mean, as a kid, I thought it was amazing. But it also made me ask a question that I still ask today as a scientist and a science communicator. What else am I missing? Because the real lesson that I learned here was that we only start to understand the world around us when we start to make it visible. And I want to show you what becomes possible when we actually start looking at what's really there. See, microorganisms have taught me more about humanity and visibility than I would like to admit. Sometimes they can tell us stories of disease, but stories of diversity and possibility. My initial story of me when I was younger was one of inspiration. I eventually saw the ultraviolet dye and thought to myself, wow, the whole world is massive and there's so much I'm missing. But this diversity that I saw on my hands is what led me to understand and listen to my heart, which is why I followed my passions into microbiology. This was where I studied a particular bacteria called Escherichia coli. Now, E. coli, you might have heard of it, is a really cool organism to me. But you might have heard of it in a negative light, because a lot of the times when it's out in news headlines, it's associated with outbreaks, particularly on food. And I promise I will get to the point. So my whole research focused on how we can look at contamination on food and use newer methods. Previous traditional methods, historical methods, would just look at contamination in general. We just look at the general community, see what's there, and say whether it's safe or not. For me, as a brand new PhD student, I stopped and asked myself, okay, but what am I missing? So this is where better tools come in. Tools like this that can sequence DNA and fit in the palm of my hand. Now, to me, as a scientist and a new researcher, I wanted to explore everything. And that's exactly what I did. And this is where I started to explore over 1,000 E. coli genomes from a range of different retail foods. And the thing that we were missing with traditional methods for looking at contamination was diversity. I created an incredibly complex family tree and found out that the methods we were using were falling short. And so this made me question all of the things that I knew beforehand. What else am I missing in the rest of my life? So I started drawing parallels between that and myself. Now, if we were to look at traditional contamination in the way that we look at maybe taking a single representative, we would all agree here that yes, a single representative does not include every single person. So if you were to take me as an example, I am a scientist, I'm a researcher, I absolutely love teaching and I love learning. I'm also Filipino, and I moved over here to the UK when I was around 2 years old because my family and my mum and dad wanted to give me and my sister a better life. I'm also part of the LGBTQ+ community, a community that has historically been overlooked and overseen in things like policy and healthcare. Alongside that, I also drew parallels within the systems that we've set in place. Of course, we have historical methods, but what else are we missing in the systems that we set for us? I exist in this really complex intersectional space. And so if you were to take me as a representative for every single person out there, you would miss what makes us unique. If I wanted to, let's say, take myself as a person and then generalize a whole community of people, you would miss the different evolutionary histories, the different capabilities that we have, and also different stories. Just like the E. coli I had found in my own research, you'd be missing quite a bit. And so this led me to understand that the systems we've set in place are also insufficient for understanding us. So, for example, with me, with the systems we set in place, I didn't know that people like me out there existed. I didn't realize that there was a lot missing. I didn't know how to ask for it because no one knew what it was like. And so I thought that I was always alone. And so I want to do a demonstration with everyone. I'd like everyone to raise your hand if you can name a scientist. Amazing. Now, let's see, keep your hand raised. Let's see if you can keep your hand raised if you can name a scientist who identifies as female. Okay, and now identify a scientist who is a person of color. now identify a scientist who is part of the LGBTQ plus community? Okay, a lot of the hands did fall. It's amazing to see that the hands are still up. Thank you so much. So when I was in my first year of my PhD, these series of questions were asked to a series of budding scientists. And I remember sitting in that room and seeing the hands fall one by one. This was where I realized possibility wasn't just some abstract idea. It was something visible and tangible to me. It became a show of hands. And then to me, in that moment, I also realized how much it mattered that my hand didn't fall. See, I always thought that I was alone, and I was actually proved wrong. During my studies, I had encountered a group of people who were unapologetically themselves. Researchers, scientists who made me feel seen, who made me feel visible. This again, just like 6-year-old Gab, was the pivot and the turning point. I joined my EDI committee and the LGBTQ plus working group in my institute, and I met so many people who were like me. But there was more to this, another layer. See, I didn't just want to meet people. I wanted to understand the systems that had made us invisible in the first place, and to see if I could change what was possible for the people who came next. I also set up a camera, and I started recording myself and started posting my stories in my science online. And I became visible in a whole new way. That was when I realized that because of the visibility, everything became possible. All the opportunities I gained was because I was brave enough to put myself out there. And it made me reflect on the inequality and the inequity that I'd also faced throughout my whole career. See, I am just one of many stories out there trying to showcase diversity. But there's also a lack of gender, identity, racial underrepresentation in science and STEM. And science, the whole purpose of it is to try and understand the world and fix problems. But how can we fix problems when historically people have always been excluded? And nowhere is this more clear on a wider scale society than the story of Jon Snow and the cholera outbreak. And you might have heard of this, but there's another layer that you guys might not have heard of. See, back in the 19th century, cholera was rampant in the United Kingdom. In the UK, it cost thousands of lives, and right now it is a disease that's still occurring in the world as well. Back then, no one really understood how infectious diseases actually spread. They didn't really have the UV light and the contamination in the 19th century. And people thought it spread through things like bad air and miasma. So Jon Snow went in to try and investigate a particularly severe outbreak in Soho, London. This was back in 1854, and he identified that there was a cluster of people around Soho, London. Now, when he was looking at this, he realized that there was a link between all of these people. This is why we call him one of the forefathers or one of the most important people in epidemiology, because he was the one to discover this. And what he found was a culprit, something that was infecting people. A water pump. So back then, they identified that, yes, this water pump was contaminated with a bacteria called Vibrio cholerae. And this was because excrement was usually thrown into cesspools or straight into the River Thames, utterly disgusting. And then it led to the contamination of waterways, which then led to drinking water becoming unsanitary. And that's usually where the story ends. But a researcher from the University of Kingston decided to look a little deeper. He decided to say, what else is there? And by using population census data from 1851, he identified something that no one else had: the socioeconomic backgrounds. Instead of having people who were just groups, generalizations, faceless things, he turned them into humans. People with ages, identities, cultures, people with lives. And what he found was that the people who were the most vulnerable were people working in clothing trade, were the ones who were working in overcrowded conditions, and those who were also younger. And this was only possible because he was willing to look at something other researchers had thought was done. And so we also face inequity right now in our current situation around the world. A part of my own research focused on antimicrobial resistance and how this is a major global health threat according to the World Health Organization. See, when researchers are studying antimicrobial resistance and looking at the global burden of it, they identified that back in 2019, there was an estimated 4.95 million deaths associated with bacterial AMR. This is a global health priority that we need to be focusing on. And we still are, but it is challenging because right now the situation itself is very, very complex. So the researchers who were looking at this also didn't just stop there and look at how many people were infected. They wanted to see who was infected. And this is where, again, the socioeconomic and socio-demographic information came in, because they identified that people who were living in the poorest countries, those who were the most vulnerable, were the ones who were the most affected. Now, the resistance we are currently fighting is partially a result of the inequity we are failing to address. But it's not all doom and gloom. Because the reason why we're here, the reason why we're fighting this, is because everything so far has made it possible. And so microorganisms have taught me so much about history, about how we evolved as people, our culture. And just like the UV light showed me contamination on my hands, microorganisms have shown us and highlighted inequity and places we can improve on in our society. And so I want to leave you with the same question I asked myself, with an addition. What else are you missing? And when you finally see it, what else becomes possible? Thank you.